Alright, today's lesson is 10-7. Our objectives for today are to find the probability of independent events and to find the probability of dependent events. You need to go ahead and write what's on this slide down. It says events are independent events if the occurrence of one event does not affect the probability of the other. So that's independent. One does not affect the other. Events are dependent events if the occurrence of one event does affect the probability of the other. So independent means one does affect the other. So go ahead and write down each one of these that are on here, and please make sure that you underline independent events and dependent events so that you know what it's talking about. Alright, so again, independent events, and you don't have to write what's in this box since you wrote down what was on the other slide. Two or more events in which the outcome of one event does not affect the outcome of the other event. It says the probability of independent events is the probability of A and B is the probability of A times the probability of B. I do want you to write down what's in the blue box. You do not have to write down what's in the purple box, but write down what's in the blue box. Probability of A and B is the probability of A times the probability of B. And that's the probability of independent events, meaning one does not affect the other.
The letter P there just stands for the word probability. The A and the B are the two different events that we're talking about.
And this is just showing probability of A and B. This is the probability that event A will happen. This is the probability that event B will happen. And what's in the middle is probability that both of those things will happen.
So you may see here, if you just glance at this, you can see that the probability of both of them happening is smaller than the probability of either of them happening on their own. Just so you kind of have that in mind as we go forward. All right, let's look at our first example. You're not going to have to write down all of the text on this slide. I'm going to tell you exactly what to write down, but please just follow along as I read this real quick. It says, an experiment consists of randomly selecting a marble from a bag, replacing it, and then selecting another marble. So you've got a bag full of marbles, and you're pulling out one marble, putting that marble back, pulling out another marble, putting that marble back. Inside the bag, you have 3 red marbles and 12 green marbles. We want to know what is the probability of selecting a red marble and then a green marble. So I want you to write down 3 red, 12 green with replacement. So you're writing down 3 red, 12 green with replacement. The reason you have to write with replacement is because it's important to know that that's what makes these independent events. It says here these events are independent. The outcome of the second event is not dependent on the first because the marble is being replaced. So no matter what we draw the first time, we're putting that marble back. So that's what makes these two events independent of each other. One has nothing to do with the other. So you've written 3 red, 12 green with replacement. And now I want you to write number 1, P for probability, open parentheses, red comma green, close parentheses, equals P times red times P times green. What this is going to look like in numbers is we have 15 marbles. We have 15 marbles. 3 of them are red. So just like we did yesterday, we're just setting up a fraction for each of these probabilities. 3 marbles are red, so it's a 3 in 15 chance that we'll pull a red marble. 12 marbles are green, so there is a 12 in 15 chance that we will pull a green marble. There is a multiplication sign in the middle because we're multiplying this probability times that probability. And then we're going to reduce our fractions. This reduces down to 1 over 5. This reduces down to 4 over 5. That's all we've done there is reduce our fractions. And when we multiply, we get 4 over 25. 1 times 4 is 4. 5 times 5 is 25. We divide that out. Gives us 0.16. So we've written it as a fraction. And you should be writing this down as a fraction, as a decimal, and now as a percent. We multiply it by 100 and we get 16%. So what this is saying is that there is a 16% chance that we will pull a red marble, put it back, and then pull a green marble out of the bag. Make sure you have the problem and all of the work written down before you move on. Number 2, a coin is flipped 4 times. What is the probability of flipping 4 heads in a row? All right, a coin has 2 sides. It has heads, it has tails. So, all right, a coin has 2 sides, heads and tails. So the probability of flipping heads for each flip is 1/2. There's a 50-50 chance it's going to be heads, a 50-50 chance it's going to be tails. So I want you to write the problem. Write coin flipped 4 times. Okay? Coin flipped 4 times. This is an independent event because it doesn't matter what it landed on last time. All that matters is what it lands on this time. The events are independent of each other. I've got 1 coin. It has 2 sides. So you're going to put P for probability, and then in parentheses H, comma, H, comma, H, comma, H to show heads, 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 heads for all 4 flips. And then we're going to multiply this out. Again, I have a 50-50 chance, also known as 1/2. One side of the 2 sides of the coin is heads. So I'm going to write that as a fraction, 1/2 for one side over a total of 2 sides to the coin. And then we're going to multiply this out. 1/2 times 1/2 times 1/2 times 1/2. And that gives us 1/16. When we divide that out to get a decimal, it gives us 0.0625. And then when we multiply that by 100 to turn it into percentage, it's going to give us 6.25%. So there's a 6.25% chance that when I flip a coin 4 times, it will land on heads all 4 times. That is not a very high percentage. Make sure that you have all of this down before you move on. All right. I'll tell you what to write down here, but listen to this as I read over it. A number cube is rolled and a coin is flipped 2 times. What is the probability of rolling a 5 and the coin landing on tails both times? These are still independent events, even though I'm talking about 2 different things here. They're still independent events because the die or the number cube has absolutely nothing to do with the coin. They are independent of each other. Okay, so these are still independent events. The die has 6 sides. I want to know what the probability of rolling a 5 is. The coin has 2 sides. We need to know what the probability of flipping tails is. So, just like it was with heads in the last problem, sorry, don't let me get ahead of myself here. Go ahead and write this down. Number cube rolled and coin flipped 2 times. Number cube rolled and coin flipped 2 times, and then write number 3, P for probability, open parentheses 5, comma T for tails, comma T for tails, close parentheses, equals P5 times PT times PT. So again, the probability of rolling a 5 on a 6-sided die is going to be 1 in 6. The probability of flipping heads on a coin that has 2 sides is going to be 1/2. And again, tails on a coin that has 2 sides is 1/2. So you should have 1/6 times 1/2 times 1/2. Hopefully you have a calculator that will do fractions, but if you don't, I'm going to go ahead and do the math for you. It's going to give you 1/24. You could also multiply that out manually. 1/24. As a fraction, we're going to divide that, and it's going to give us 0.0417 as a decimal, and then we're going to multiply it by 100 to get a percentage, and it's going to give us 4.2%, meaning 4.2% of the time that I roll the die and then flip a coin twice, is it going to land, or is it likely to land on 5 tails and tails? Again, these are still independent events. Make sure that you have all of that down before you move on. All right. The last independent event we're going to look at is an experiment consisting of a spinner. And we're spinning the spinner twice, and we want to know what the probability of spinning two odd numbers is. If you'll notice on this spinner, and I want you to write down, hold on. I want you to write down spinning spinner twice. And then you have here number 4 is the probability, open parentheses, odd comma odd, close parentheses, equals P odd times P odd. What is the probability of spinning an odd number on the spinner? If you look over here at the spinner, you have 1, 3, and 5. So I have 3 odd numbers out of a total of 6 numbers. So 1/2 of this spinner is odd. So I have a 1/2 chance of spinning an odd number. If you were to say, okay, literally you have 3 odd numbers, so 3 over 6, it's still going to reduce down to 1/2. So 3 over 6 is still going to reduce down to 1/2. So I write probability odd, which is 1/2 times 1/2, which is going to give me 1/4 when I multiply it out. Divide it out to get a decimal, and it's going to give me 0.25. Multiply that by 100 to get a percentage, and it's going to give me 25%. So there's a 25% chance of spinning the spinner and landing on two odd numbers. They're not necessarily going to be different odd numbers, but 2 odd numbers, because half of my wheel is odd. Each spin has nothing to do with the previous spin, so that's why these are still independent events. Make sure that you have this work down. You don't have to copy the spinner. All right, so we found the probability of independent events, and now we're going to look at the probability of dependent events.
All right, so now we're going to find the probability of dependent events. So suppose an experiment involves drawing marbles from a bag. Determine the theoretical probability of drawing a red marble and then drawing a second red marble without replacing the first one. So here it says the sample space for the second draw is not the same as the sample space for the first draw. There are fewer marbles in the bag for the second draw. This means the events are dependent. Basically, if we're not replacing them, then here there's 3 red marbles in this bag, and then there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles total. So that's what it looks like the first time I go to draw out a marble. Now, if I take a red marble and I don't put it back, the second time I go, there's 1 less red marble, and there's 1 less of the total number of marbles in my bag. So that affects my probability the second time. The probability of drawing a red marble on the first draw is 3 out of 9, because 3 out of the 9 marbles in the bag are red, which is 1/3. The probability of drawing a red marble on the second draw, there's only 2 red marbles the second time, and there's only 8 marbles total. So that's 2 out of 8, which is 1/4. So these two probabilities are different. So dependent events are 2 or more events in which the outcome of one event affects the outcome of the other event. You do not have to write what's in the purple box. You do need to write down what's in this blue box. The probability of dependent events is the probability of A and B is equal to the probability of A times the probability of B following A. Meaning that the second time we're going to assume that A happened and we're going to find the probability of what's left. And again, it says right here, taking a marble out of the jar and not replacing it is an example of a dependent event. So again, all you have to write down here is what's in the blue box. Number 5 says a bag has 10 red marbles, 12 white marbles, and 8 blue marbles. What is the probability of drawing a blue marble, not replacing it, and then drawing a red marble? So this is what you need to write down: 10 red, 12 white, 8 blue, and then without replacement. You need to write without replacement because that's how we know that it's a dependent event, meaning that one's going to depend on the others because we're not putting that marble back after we pick it out the first time. And then you need to write probability of blue and red equals the probability of blue times the probability of red after blue. Alright, so let's look at this one. First is the probability of blue. Well, there's 8 blue marbles in our bag. In total, if I add all these up, I get 30 marbles total. So 8 marbles are blue out of 30 total marbles in our bag, so that's our probability of blue. Now for the second one, which is kind of what makes this a little bit more difficult, is we're wanting to know the probability of red after we've picked out that blue marble. So we're going to assume that we picked out the blue one the first time and we did not put it back. Now there are still 10 red marbles in our bag because we didn't pull out a red one, we pulled out a blue one. So there are still 10 red marbles left, but there are only 29 marbles total now in our bag after we picked out the blue one. So we have 8 out of 30, or 8 over 30 times 10 over 29. And we're going to multiply these, so we get 80 over 870, which reduces to 8 over 87. So then we need a fraction, decimal, and percentage. So I'm going to say 8 divided by 87, and I get 0.091954. We're going to shorten that to 0.092. Then we're going to either multiply this decimal by 100, or we're going to move the decimal place to the right 2 spaces, and we get 9.2%. You need to make sure you have the reduced fraction, the decimal, and the percentage. So make sure you have this written before you move on. Number 6 says 10 cards are numbered 1 through 10 and placed in a box. Once a card is selected, it is not replaced. What is the probability of selecting 2 even cards? So you need to write 10 cards numbered 1 through 10 to tell what it's about. That way you don't have to write this entire thing. You just write 10 cards numbered 1 through 10. Okay. And the picture here is kind of deceiving. We're just saying that we're taking cards and placing numbers 1 through 10 on them. We're not doing the whole ace, diamond, all that stuff. So here we have the probability of picking an even card, and the probability of picking an even card is the probability of even, and then the probability of even after even. Make sure you have that written as well. Now, on numbers 1 through 10, we're looking for even numbers. So that would be 2, 4, 6, 8, and 10. So that is 5 out of our 10 cards are even. So 5 out of 10. So that's our first one for our probability of even. Now our probability of even after even. So we're going to assume that we've picked out one of those even cards and we've not put it back. So we only have 4 of the 5 even cards left, and we only have 9 total cards left to choose from the second time. So we pulled out an even, so there are only 4 evens left in our stack of cards, and there are only 9 cards left if we took out an even and did not replace it. So 5 over 10 times 4 over 9 gives us 2 over 9 reduced, which is 0.222, or 22.2%. Again, you need to have your reduced fraction, your decimal, and your percentage for that. Make sure you have all that written before you move on. Number 7 says 9 boys and 11 girls can be selected to participate in a survey. What is the probability that the 2 people selected will be boys? So we have 9 boys and 11 girls, and we're going to do the probability of a boy and then probability of a boy. So probability of boy and then probability of boy after a boy is chosen. Okay. We know that this one is dependent because they want 2 different people for their survey. So we can't pick the same person twice. So we know that that's going to affect the probability the second time. Okay, so the first time, the probability of picking a boy, there are 9 boys out of 20 people or 20 students total, because 9 boys and 11 girls give me 20 altogether. 9 of those 20 are boys, so 9 out of 20, or 9 over 20. Now it says probability of boy after a boy. So if there are 9 boys to begin with and I've already picked a boy, there are only 8 boys left and only 19 more people to choose from. So there's only 8 boys left, only 19 students left if I've chosen a boy the first time. So I multiply those and I get 18 out of 95, or 18 over 95, which is 0.189, or 18.9%. So again, to get these, I divided 18 by 95 and got 0.189. Then I either multiplied that number by 100, or I moved that decimal place 2 places to the right and got 18.9%. Make sure you have your little percentage right there. Make sure you have all that written before you move on. Alright, so there's finding the probability of dependent events. Alright, I want you to go ahead and work each one of these before you go. So there are 4. On 1 and 2, you're just telling me independent or dependent and telling me why. And on 3 and 4, you're actually finding the probability of each one of those events. So go ahead and pause your video and try 1, 2, 3, and 4. Alright, hopefully you've had time to pause the video. The first one is independent. The first coin does not affect the second coin. Number 2 is dependent. There are fewer cards to choose from when drawing the black card. Number 3, you should have gotten 3 out of 28. And on number 4, you should have gotten 6 out of 25. And I'm hoping you did that as a decimal and a percentage as well. But if you did not get those correct, please make sure you go back and find your mistake and fix those. Or if you don't know where your mistake is, please ask us tomorrow and we'll look at that for you. Alright, go ahead and write down your assignment. It's 10-7, page 754. You're going to do number 7, 8, 10 through 14, 17 through 22, 29, 49 through 51. Notice it says find the probability for every problem. So that's going to be your assignment tomorrow in class, is to find the probability of each one of those problems. That is the end of your video. Thank you for watching.